Hi, folks. Sorry about that. I was somehow had the old meeting invites. It's still linked into the GoToMeeting, and I don't see Hemel yet.
I think you're on the wrong headset.
Oh, no, another one of those. Hold on.
Come on, Jeff. Get it together.
I'm going to promote you to chairman if you're not careful there, Justin. There it is. Yeah, and of course it's all right. Ah.
That's funny, Jeff.
Well, I don't see Hemel. I don't have any notes from him. But tell you, since we got a presentation, let's go ahead and get started. So call this meeting to order. Yay! Monthly meeting for the of the hardware management sub-project for OCP. So just a reminder that the meetings are recorded, and those recordings get posted on the website. So with that, on today's agenda, we have a presentation from Justin at Google regarding GPU management and some of the work that's going on there, and a bunch of topics. So and Justin, I think I allocated you half an hour for that, but so take it away. Before we do that, the only other things I had on the agenda were just updates from any of the project substances. Any of the work stream leaders have anything they need to discuss? Just want to make sure we have room for it if folks have.
Hey, Jeff, this is Chad from Google. I also had a presentation ready for machine health rules. I don't know if that was on the agenda or
not. If it, hopefully it wasn't something I did, but I did not see that, but assuming we have time, we can. John, was there something there? Did I miss it?
Yeah, so he had formally made the presentation to you and I and asked how he could get community formed. And we suggested going to this hardware management project. It's unclear whether a request ever made it across, or it's just assumed that it would be plopped on the agenda.
Sure. Okay. Yeah, sorry about that. Having this agenda over on a different topic.
So given given that we're short on time and you asked me open, I'll get an open even though Han's here and he may speak in. But we bumped open RMC profile to 1.0.3, and this was actually to fix issues being found in testing of Device Manager. So Device Manager actually implements OpenRMC, and so they're doing full-blown testing, and they found a couple of typos in the profile itself. So we bumped that there to make their runs clean. And we also submitted an abstract to regional, and this was to demonstrate or announce the release of OpenRMC with a Redfish interface on top, which has the aggregation model. And it will also be present in the Experience Center. So the goal is to have a rack manager there, which Mark Chet will bring, and to invite other companies who want to bring managed nodes who support the baseline to also be part of the Experience Center. So they could demonstrate how Rack Manager could manage servers or network equipment or storage equipment as long as they meet the baseline. That's it.
Okay.
Thank you, John.
All right, let's get into let's see if we can get both those presentations in today then. So Justin, take it away.
Yeah, and I'm going to actually turn it over to Bhushan and Sujoy, the part of the presentation that I'm working on with NVIDIA. And Microsoft didn't make it this go around, so Bhushan or Sujoy, take it away.
Yeah, sure. I'll share my screen in a second. Okay. Let me know when y'all can see this.
Yep.
Yeah, awesome. Sujoy, do you want to take it off from the first one?
Sure. Thanks, Bhushan. Thank you, Jeff and Hemal, for penciling us in today. Excuse me. So just as a, just as a sort of background of why we are here, and some of you are aware of this and some of you may not be, so we thought maybe we'll give you a little bit of a background first and dive into some of the specifics. So as many of you are probably aware, we started this GPU sort of OCP effort to standardize various facets of GPU manageability. And we sort of started this more than a year ago. And we have three, primary work streams: one on manageability interfaces, one on RAS, and one on firmware update. And we released a set of specs in fall or late summer, early fall last year for all of these three work streams, which we then talked about in the OCP summit in October. And now we're sort of back here with a 0.9 version. So we had released, the 0.5 versions for the RAS and the manageability interface workstream specs, and a 0.7 version for the firmware update specs. And now we're sort of at a 0.9 level. So we wanted to sort of come back and present what that's about. Essentially take a quick 10 minutes or 20 minutes to present what that's about. We'd like to, we wanted to come and do all three, but like Justin said, the management interface needs a little more time. So they'll come back hopefully in a few weeks. And then we're going to go ahead and publish 0.9. So that's that's why we're here. So we'll go through just a refresher on, again, why we are doing this as a whole, since it's been a few months since anybody sort of spoke about this in public. And then we'll cover the firmware update workstream, where we are. And then, of course, we'll cover the RAS. And then we'll end there. So, Arun, Bhushan, if you want to maybe take over.
Yep, absolutely. So a couple of things, just to refresh everybody's memory. There are a couple of problems that we encountered when we started with the whole AI proliferation, right? where a lot of bespoke tooling was sort of being brought in from suppliers that us as hyperscalers were consuming, right? And there were some quirks between different revisions of these products, as well as, you know, us needing to adopt a lot more supplier-specific hardware. And so what we decided to do was sort of look at standardizing mechanisms in a hyperscaler agnostic way, so that suppliers can work with multiple hyperscalers when it came to accelerators and GPUs, and at the same time open it up for you know, suppliers as well to be, you know, compatible with a lot more hyperscalers. So, you know, both parties benefit in this particular paradigm, right? And essentially the way we formed this was working with a small collaboration with NVIDIA, Microsoft, and Google to start off with. We, you know, started off the CLA around Q4 of 2022. And we focused on 3 areas, because this is a vast area to sort of standardize and take a look at, right? And we split it broadly into, you know, sort of looking at interfaces, how, you know, OpenBMC can start to synergize with what the suppliers were bringing. The second aspect we looked at was RAS, because this is very near and dear to hyperscalers, right? How can we make sure that, you know, things are reliable, available, serviceable, right? In this particular arena. And then one of the parts that was, you know, that hyperscalers were focusing on was the aspect of firmware update, right? I mean, it's update, there is, you know, not a lot of IP in there from, you know, moving it forward in terms of standardization. But, you know, how do we sort of standardize it so that we can focus more on the innovation on top of these stacks, right? As opposed to getting the bits onto the hardware, right? And our approach is to work you know, on requirement specifications, as was being alluded to, and then also marry it with what we call as CTAM, or compliance tool for accelerator management, to sort of like kind of say, hey, let's speak the same language, both hyperscalers as well as suppliers. And the idea was that this tool would then go and, you know, have a checklist of things that the specifications are asking for, and to the best of its ability, go and validate or go and look at the things compliance, right? What is being done in terms of the spec, right? And in terms of the tenets, I'll hand it off a little bit to Vishal from NVIDIA, if you talk about the tenets that we are trying to take a look at as a part of this, right? Which is, you know, a key part of our mind when we are designing all of these to make it OCP compatible. Go ahead, Vishal.
Right. So, can you guys hear me?
Yeah.
Okay. In terms of tenets, right? As I'm gonna just paraphrase what's written on the slides here. Openness, efficiency, impact, scale, and sustainability, right? So what we figured out was a lot of manageability protocols were proprietary. So we are in process of developing specifications that are open to industry, right? People can come in and participate and make these areas, you know, adaptable to changing needs, right? We also want to make sure, you know, the specifications that we are standardizing are impactful, right? For example, all the 3 work streams that we have, firmware update, manageability interfaces, and RAS, they have profound impact on GPU integration in hyperscaler land. At the core of the specification is at scale deployment, right? Everything that we are doing, we are making sure that when we deploy GPUs, they can be, you know, they can be managed, monitored at scale, right? And lastly, and you know, we want to enable frictionless deployment of these standards across generations of GPUs, which are yet to become the mainstream of the industry. With that, maybe Sujay or Bhushan can take the next step.
Yeah. So what I'll do is so Sujoy or Carlos, do you want to take the firmware update? Sujoy, maybe you can take it.
Yeah,
Go ahead.
I'll go ahead and take it. So we sort of will dive into a little bit on GPU firmware update specifically. If you go to the next slide, please. So a quick refresher on what's in point 7. So essentially, we did this whole presentation and somewhat of a deeper dive for GPU firmware update under the OSF project. Last time we released point 7, and since then, through various conversations, it was decided that the firmware update part will also live under hardware management project. It sort of makes sense to live here. So hence, we are coming here to this committee or this project for the first time. So what, excuse me. Sorry, haven't had my morning coffee yet. So what we've really focused on is a few things that as capabilities that we want to standardize. Essentially, the behavior of GPU and GPU subsystems with respect to how firmware update should operate, so that it can be done fairly painlessly and managed fairly painlessly across hyperscaler fleets. And there are sort of 4 areas that we focused on. We focused on, both defining the semantics of these capabilities, like how these should behave, and of course the interfaces that Vishal talked about with respect to protocol and interfaces to standardize the operation of these capabilities. So the first one is secure sort of upgrade and downgrade, and this is we've basically what we put in the spec is everything from what the image signing requirement should be, what the time for an update, on an average sort of should be, what are sort of disruption versus non-disruption requirements of different phases of firmware update. We've defined a very clear demarcation of what we call a copy versus ARM versus an activate phase, where copy is when the firmware is actually getting, essentially copied into the device across the fleet, which is we've required that to be non-disruptive in any way, and then we arm it so it's ready to go as still non-disruptive, and then of course the activation still can be disruptive. So things like that, which a lot of this was sort of happening on an ad hoc and sort of proprietary vendor and hyperscaler specific basis. So it's not a lot of new things that we invented. It's really about taking those and putting it down on paper and agreeing that this is a set of common set of requirements that GPUs need to adhere to. Similarly, what does rollback and anti-rollback actually means? And then we looked into the image requirements. We've standardized as much as possible on using existing standards, PLDM, Redfish. So image requirements around PLDM packaging. But we've put in things like, what the image size might have to be, how do you package multiple images, things like that. And then a very big area of focus was resiliency and redundancy. So things like how should firmware update behave, in an event of a power loss, while the update is happening. What should be the redundancy requirements architecturally, if you will, right, for storing redundant images. And then when there are faults that occur, how should they be recovered? This is a fairly big pain point. It's a fairly big topic by itself. It's also a big pain point today. And then last but not least, really standardization around the telemetry that we all feel that is important. That every sort of firmware update, firmware package, firmware itself needs to provide, right, both in terms of metadata, but also in terms of logging, for example. So that's sort of what we are at point 7, which is already out there. So if we could go to the next slide. So what did we do in point 9? Well, we did a bunch of cleanup, of course, like we usually have to do. But beyond that, we focused on a few things. We looked at what is the failure semantics of a single firmware update that may fail when we're updating a bundle. So our default expectation or requirements is, for that all components that require sort of mutable firmware in a GPU subsystem, be packaged together, as part of a single sort of firmware update operation. But the question came up: what happens if a single device update actually failed? So we will consider that as a failure. That's what we've defined here. But then optionally, we have said that a single device update can be supported, sort of single device package. But if it is supported by the vendor, then they need to support it via the push URI targets API in Redfish.
So, Sujoy?
Yeah.
For your bundled update failure semantics, do you deal with the fact what happens with a single piece of firmware fails in a bundle? Do you do an auto rollback of everybody else because all that firmware needs to be installed completely or not at all? Or how do you even deal with those semantics at all?
Yeah, actually, Vishal, do you want to take this?
Sure. Yeah. So, John, yes. So what happens is, so, we have a redundancy play in, right? So if a firmware update is failing, we will restore the slot that we are updating from the backup slot. So it tries
No,
to
that's
bring them.
that's not the
Yeah.
question. That's not the question.
Mhm.
You're creating a bundle of firmware, BMC and BIOS, right?
Mhm.
And they have to be installed together. So you bundle them together and you say install both. So BMC fails. So does that mean BIOS gets rolled back?
Okay, yeah, no. So yes, we specifically talked about that.
Okay.
The onus of maintaining, integrity around, or compatibility around components is a orchestrator job. So if BIOS firmware update failed and BMC passed along, then the orchestrator need to reinitiate firmware update to bring the other component to the required level. So we do not do
Okay.
automatic remediation.
So there's no bundle policy that goes down with the
Yeah.
bundle
No.
to say what happens. Okay, thank you.
Yeah,
That's what I wanted to know.
That's why we consider the whole thing as a failure if one fails.
Is there a reason you're calling out HTTP push URI targets? Because that's a proprietary and deprecated approach to firmware update.
So yeah, this we hyperscalers need while we move towards a multi-part HTTP, we currently support HTTP push URI targets. We want to maintain support of that while we migrate over to multi-part.
So will you be pulling out the HTTP push URI options? Because I think we advise most implementation these days to not even implement that approach since it's all vendor specific.
No, so hyperscalers have already implemented those URIs. So as a company, we don't think we're gonna pull that out, but we can define a cutoff where we will switch over to multi-part altogether.
Can you support? Is there any indication of supporting both?
You-
So
you
that
can-
if I want,
Yeah.
so if I want to implement this, I just want to do push multi-part. I can do push multi-part, satisfy this. Or will my implementation of the multi-part be non-compliant against this spec?
So while you can support both, my concern is if you go out the door with a specification that recommends a DMTF deprecated approach, that seems to be doing a disservice to folks.
I agree.
I'd rather go out the door with multi-part required, and then if you want to optionally support the older HTTP push URI, then by all means go ahead and do that.
Yeah, yeah, I think so. The requirement is to support the multi-part. This particular thing is for two reasons. One is, like Vishal said, to sort of we want to support backward compatibility while the the new APIs get implemented by everybody, right? And then phase
Right.
this one out. So that's one reason. The second one is the single device update is something we want to discourage. We want to basically be able to do certainly support only package. So we made this selective, sorry, not selective. We made it optional, and we've kept it as the current sort of legacy method because that's what's supported. But eventually this will be deprecated, I expect.
You can still do selective update with multipart. It's a target parameter that's defined in the JSON body of the multipart request. So there's no usage of that HTTP URI targets property. It's all embedded as part of the multipart request.
Yeah, except not all devices are there yet.
Right. So this is merely a matter of what normative language you want to put around this, right? If you say it may be right HTTP push UI, or it may be multipart, that's one thing. If you say one is mandatory, then that directs people. So what is your spec going to say? Is it either one or pick one?
So we're saying the multi-part is where we want to be. It's saying, that needs to be supported.
And how is that spec saying that? Is it saying we prefer you do multi-part?
Is it a shall, a should? Is it a may? I would opt for it shall support multi-part, and it support HTTP push.
Yeah, this is good feedback. I think that's what it says. I have to go.
Okay, thank you. That's
yeah. And John and Michael, what we can do is we can share the language with you, right? And this is a great feedback. This is why we're having this, right? And we can totally revise it.
Thank you.
The other thing, just to continue, one of the other things we've done is we're decoupling the update of the package, the firmware update package, from updating the min-SVN on the device. And this is actually a fairly important thing we're trying to accomplish, which is because in the hyperscaler world we have lots and lots of machines. The fleet that we update, we want to make sure that if there's a firmware update that's going to burn the SVN, update the SVN, min-SVN, we want to make sure that it's good, it's got its soak time, and it takes sometimes days or weeks to update the entire fleet, and then sort of burn the min-SVN once we're happy with it. So that's sort of an area that we updated the language in the spec. And then lastly, this is actually not a firmware update spec specific thing in the spec, but the compliance tool that Bhushan talked about, that of course is open source, but they've also created the PLDM package bundling tool that's also open source as part of this 0.9.
Sujo, simple question. What does SVN mean?
Oh, security version number.
Thank you.
And then to 1.0, just looking forward, we would like to standardize the copy and ARM support in Redfish. The current support is not quite what we need. So we're going to be working with DMTF on that, as well as this min-SVN update in Redfish that also requires an update. So this is actually the reason why this is 0.9 and not 1.0, because we'd like to get that standardized if possible. Working with DMTF.
The only thing I ask is that when issues are coming in across from this workstream, can we have it annotated in the issue when it's filed? So we know it's not coming from an individual company, but it's coming from OCP workstream, which represents many. We kind of do the same with OpenBMC. So we know
DMTF, you mean?
Yeah. So
okay.
When it comes across, I mean, because I think I know the issues that were filed against this, and I had no idea that it was attached to these sets of specifications.
Yeah, that's good feedback, John. We can quickly do that. Yeah.
Thank you.
That's it for the firmware update. I think turning over to Ras now.
Yeah, so I think Rama, are you on call? Sorry, Vishal, you had your hand raised. Do you want to go?
Yeah.
Yeah, go ahead.
Yeah, I just wanted to, I think John alluded to that. We wanted to get some guidance on how we should approach DMTF for the multi-part HTTP support with respect to accommodating copy and ARM workflows that we envision. So I think we'll file those bugs with OCP workstream and take it from there. That's all I have.
Thanks, Vishal. Rama, do you want to take on?
Yeah, thank you.
Good. Yeah.
Yeah. Last time, like when we met, we contributed the 0.5 specification. Okay. And right now, like as a team together with additional members from AMD Meta, okay, we worked on 0.9 spec. Okay. Just to give a recap, 1 minute is summary is 0.5 spec. We spend energy on what are the goals for the specification, what are the common problems that faced by cloud-based provider. Then we worked on the error injection, capability standardization, and then last thing we did was we leveraged the previous hardware fault management contribution about CPER, how do we report errors with Redfish. Okay, that was in 0.5 spec. And in 0.9, we improved it on existing 0.5 some content, but with little more clarity with the additional feedback from team members after OCP tech talk and some of the feedback we received. And in addition to the existing content review, we added this GPU and system crash debug dumps. Like if you see the systems have many components, okay, for debuggability and analyzing the failures, okay, we are like standardizing this crash dump format. First it goes through capability APIs, what is the crash dump record standardization. Once you get the crash dump, we would like the silicon vendors to provide the analyzer tools, that has a tool analysis requirements and analysis framework. And wherever possible, we try to leverage the existing OCP specs or other industry standards instead of creating new ones. Okay, and specifying the gaps and improving for a GPU level. That is the main major contribution in 0.9 spec. Also, at high level, we went into PCU GPU fault management requirements. I would say this is at a what are the critical features or pain points to address that. Those are the high level things we listed there. Okay, 1.0 is the one we are putting more energy on expanding this in depth into all type of RAS feature requirements, like memory, PCIe, GPU, all the subcomponents on the system. And that will be part of 1.0. We just have started the early draft. And last thing is we added a tools. What is that compliance tools RAS should focus on? We just provided some overview, and it'll be little more details will be added into next revision of the spec. And yeah, I would like to NVIDIA, Google, AMD, Meta for close collaboration on this. We have a weekly syncs. And any questions?
You said you just started 1.0, so when is that targeted? Is that first half?
1.0?
Yeah.
We didn't have timelines. Maybe Bhushan, you want to take we are looking at all three specs going 1.0.
Yeah, John. So what we're trying to do is to minimize the whole burden of FSA signing and so on and so forth. We're trying to combine all of these into one go. Our goal is to sort of try to see if we can get something within the next quarter out. But if you want more tighter timelines, and granular timelines, we can share that with you, right? But that's roughly how we are planning to do these things. Yeah.
Okay, and I assume that the version 0.9s are going to be contributed sometime soon?
Yeah, so what we were hoping to do as a part of this effort is share it with this forum and see if there's a way to put it up on the, the wikis essentially that this forum has, so you all can take a look at it, right? Like, those are ready, at least for these two forums, right? And when Justin Chowdhury and company are good with the interfaces, we'll do the same as well, right? So that way we're not keeping it, from all of you awesome folks for a longer time, and then when it actually comes up, we can go through the incubation committee and put it all up officially.
Okay.
Would that be okay, John? Yeah.
Yeah. In general, when I've seen this done before, and Chen, you can correct me, is that I think you need to sign a CLA, or I got to figure out if you have to sign a new CLA or an FSA for this version 0.9 as opposed to the earlier versions. But besides that,
Yeah, we are already under the CLA. If you need an
Okay.
FSA, please, I'll be happy to facilitate that. Not a problem.
Okay.
Yeah, John.
Yeah.
So our understanding is that if you guys, if the hardware committee is good, we can put this up in the wiki without the FSA, which what Bhushan was alluding to. That's what we'd like to do. And
Okay.
then once we already have a CLA for this, and then once the management interface is ready, hopefully in a few weeks, then we'll sign the FSA, and then so that can be put into the regular OCP contribution.
Okay.
No, so sorry, I'm lost there. Maybe we can take it offline. I'm still under impression we cannot put it on public wiki until FSA is signed. So let's get that clarity before we push the spec out on any public wikis.
Yeah, John, I'll send an email to you to see what the rules are around this. I don't want to spend other people's time here. Yeah.
Right. So you asking for approval here or sometime later?
No, I'll send you a
in the
note
project?
so that way
Okay.
we save time in this forum. Yeah.
Okay. Thank you.
Cool. Thank you. Any other questions, concerns? Cool. Thank you so much for your time, everybody.
Thank you.
I'll hand off to Jeff. Go ahead, Jeff. Yeah.
All right, and we've got
Thank you all. Bush, I had to drop off. Thank you all. Yeah. Bye.
Thanks, Rama.
Bye.
all right, and we've got ample time here to get into the other presentation. John, I'm sorry, who was lost the?
Jeff, that's me, Chad from Google.
Yeah, go ahead, Chad.
Okay, sure. Let me share my screen. Yeah, this is something that, let's see, is it sharing?
Yes,
Can you
it's sharing.
Oh, it
Yes,
is sharing. Okay.
Mm-hmm.
Yeah, so this is a proposal to standardize monitoring using Redfish, monitoring of devices and data centers for hyperscalers. So what is the proposal? So if you look at the diagram in the right, you see what is standardized today are the Redfish data telemetry and control to the machine through the BMC or other health agents. Interop profiles are standardized, which validate properties and actions, and it can include things like conditionals on values within returned data. What we're proposing is an extension of that. So let's say after the interop profile validation happens, taking the data as a time series of data, then applying health rules to that time series of data, using that to produce symptoms that then invoke repair actions. And so it's this box, this dash box on the bottom right, that's the scope of the proposal. And so just to talk about time series data somewhat, it's think of all the data that's being returned. So at Google, the way that things work is that we're kind of fetching over time every n seconds or so the redfish data, or you could imagine the data gets pushed to the cloud. But if you look at all of that data, sometimes it's symptoms or repair actions aren't triggered by the actual data itself, but operations against the time window of that data. And so you could have over a, in this example, I have a confidence interval of 2 hours that you're looking at a window of data, and then conditions can operate on that. And so what the window would let us do is support things like rates, deltas, and counts over different time windows. A good example is correctable memory errors. And so a single correctable memory error may not mean much, but multiple correctable memory errors over a short period of time may let the hyperscaler know that the memory should be replaced. And some repairs, at least at Google, are time series dependent. So if you have a hot CPU, maybe that's okay for a short period of time, but if you're continually signaling a hot CPU, that could indicate a repair action is warranted. I'll just pause here for any questions. Or does this make sense so far?
So all this would exist outside the platform in orchestration.
Outside, yeah, that's right. Outside of the monitor platform.
So, Chad, this is Vishal from NVIDIA. So, in short, you are saying, let's make primitives richer, and we will do all the knowledge gathering from these primitives via some offline workflows.
That's right. That's right.
Okay, cool. Thank you.
Yeah.
I like this.
And this is an example of what the language looks like that we use at Google. It's a simplified version of the data tree, and so we're using RedPath to extract data. And so we have queries and subqueries, and those get mapped to property key value pairs. And so this is somewhat of an implementation detail, but it does make the health rule writing easier. And so at the top, we see a RedPath that extracts data from the redfish data, and rules language then operate on that data. And so the top is just the extraction to put it into essentially a bag of data. And on the bottom, we have a simplified expression. In this case, it's saying if over the time window, we have excessive drop packets, then some signal gets generated. And so the idea is that these health rules and queries could be shared across hyperscalers. One thing it does enforce is that the structure of the redfish tree, which is we consider a good thing because redfish is so capable that many things can be expressed in many different ways. And what this does is it places some constraints on the redfish tree. The end goal is that we could take an off-the-shelf device, plug it into the data center, and that off-the-shelf device could be matched up to health rules, and we could instantly monitor that device. And just a little more details on the health rule language that we're using today. There's the pre-processing step, which is gathering the data from the redfish tree and mapping it into those key value pairs. We identify what the symptom would be. In this case, it's packet loss. And there can be some pre-processing of the data, so specifying for this particular health rule that we're only interested in looking back 2 days, so 48 hours, and what the properties that we're interested in. So why do we want to do this? So we have we found that this makes the writing of the health rules simpler, and we can share it from platform to platform. And one of the biggest reasons I like it is that it enables test-driven development. So at Google, we work with different JDMs to help us do device bring up. And we're often giving them requirements documents, but what we really want to do is be able to give them the tests or the health rules. And then they can code against that. So they, we give them the health rules, where in this case they would be standardized. They could run it in some environment, and those tests would initially fail or generate symptoms, and they keep developing until the tests pass. And once those tests pass, then we can be assured that the functionality is complete. And one thing you can think of is that rules could be shipped or associated with off-the-shelf devices, similar in a way that devices have device drivers. The devices could have associated health rules, and those rules can be aggregated together and shared across hyperscalers and rule libraries. And not only the symptoms could be shared in the health rules, but also the repair actions. So what action one takes. And typically, so at Google, there's some broad actions like reboot, reinstall, replace through, but it can get much more detailed than that. And like I said, the end goal really for us is low-cost integration or zero-cost integration of devices. So off-the-shelf devices or off-the-shelf components that we can plug in, and things just quote unquote work. Yep, and that's the end of the presentation. Any questions?
So I think the point of this presentation was to determine interest within the community. And for those who are interested to contact you because you'd really like to launch a work stream to have this discussion.
Yes, that's right. Yeah, we're looking for partners to help us explore this space and standardize. So other folks interested, and it could be from different areas like off the shelf or hyperscalers or folks otherwise interested in this.
I see this with a much broader application than just your GPUs. This could be air cooling, liquid cooling, power supplies, anything like that, the instantaneous data wouldn't show a failure, but your time series data would show a trend towards a failure.
Yeah, that's right. And today we're using a combination of like fairly simplistic health rules, but one could also imagine some machine learning applied to the time series. We would have to explore what that looks like.
Yeah, but I can see other groups like the liquid cooling group or power supplies or anybody being very interested in the health monitoring side of this.
Oh, yeah, that's a good point. That's true. I agree with that.
So I have a question regarding the health monitoring. Regarding the time granularity, if I don't remember wrong, you said every 8 seconds covered 2 hours. Is the correct statement?
Oh, the time windows can be different, and the frequency of collection could be different. And so at Google today, I think we're collecting on the order of sub-minute.
Sub-minute, okay.
Then the windows can be large or small. Some errors may be catastrophic, and one would want to react to them immediately. But for others, I think the time windows can be on the order of hours or days, but typically that's as long as the hysteresis lasts or the memory lasts. Would just be over, I think max a couple of days.
Okay. Do you see a trend to push to sub-seconds? It might have some data storage concern and so forth. So just see whether this is a future requirement or something.
Yeah, that's a good point. For higher speed telemetry, more frequently collected, there may be storage concerns eventually. Yeah.
Okay, thank you.
Sorry, I mean, Chad, do you have a, if you can, I want to see if we can get the presentation posted and, was gonna put your email. I can remember put it in the chat. I'll put that in the minutes, because I think at this point, the next step would be to get folks to get in contact with you and see if we can get, or they can contact us too, obviously, but see if we can get some enough critical mass and interest just to if this is worthy of a work stream, and obviously folks can y'all can meet. Yeah, a small group can meet together, and then if there's enough of that, then we can go kick a work stream off to have a more formal OCP participation there.
Yeah, that sounds good. I put my email in, and I'll
Yeah.
make this. I'll send you a link to it. I just want to make sure I got the sharing settings set up correctly.
Very good.
Okay. Great.
All right. Let's see. We have a few minutes left. Were there any of the other any of the work stream folks that had any updates they wanted to mention today? And John, I kind of half captured the things that you'd put, so I may need to update that. Okay. Well, not hearing much. Is there any other topics for today? All right. Well, we made it through our agenda with a couple minutes to spare, which is always it's always good. So, with nothing else, we'll end the call for today. Thank you all for attending, and we will see you next month.
Thank you. Bye.
See ya.